All right, there we go. Hey, the Hangout on Air is live. Hey, welcome everybody. It is 2 hours UTC, and it's time once again for Astronomy Daily Live. So, hope everybody's doing well out there in the universe and the world. Things are pretty good here. I've actually, as you can see, the orange 8-inch telescope is not behind me. It is actually outside waiting for it to clear up a little bit. And hopefully tonight, one, it has to clear up, of course. And then two, the humidity has to cooperate a little bit. Last night, it was perfectly clear. Seeing was relatively okay. I would say a little bit above average, I guess. And it was great, and it was fun. It was getting dark, and I had actually slewed to the target object of the night, which is Messier 46. And just sort of, waiting for it to get dark. Astronomical twilight. Actually, I can look that up here. Astronomical twilight at my location for tonight, local time, is 7:39 p.m. So that's in about 37 minutes from now. It'll be astronomically dark, which means that the sun is officially 18 degrees below the horizon. There are actually three different twilights, right? There's civil twilight, there's nautical twilight, and there's the astronomical twilight. And so yeah, once I pass through the astronomical twilight, it's officially dark, and I can actually start being assured that there isn't any more atmospheric scatter from the sun. At least I have to worry about the atmospheric scatter from all the stars, but that's sort of a different thing. Anyway, so I hope everybody's doing well out there. I'm gonna check the chat really quick. Very good, excelente. So yeah, I hope everybody's doing well. As I said, things are good here. So why don't I welcome on the panel once again from the American Southeast, Bobby. Hey, what's going on?
All right, from all right. You could also just say from about like maybe I forgot how many miles to the Gulf of Mexico, but I'm like super close to it.
Super close to the Gulf. Now, some people call that the South, right? The South. And I sort of have a problem with that because I'm in the South, right? But they don't call the Southwest the South, right? So it's just this.
The Southeast is also known as the Deep South.
The Deep South, yeah, the Deep South, which I mean, we humans, we have these strange names for things, right? And unless you sort of grow up with it, or it's like it doesn't make any sense, right? It's like the Midwest, right? The Midwest, the Midwest is east of me, so why am I calling it the Midwest? It's just ridiculous, right? But it's part of the vernacular, right? It's the same thing, right? It's exactly the same thing as saying sunrise and sunset, right? That is the most ridiculous concept. The sun is not moving in that way, right? The Earth is rotating this way, right? West to east. So it looks like the sky is moving east to west, right?
And from
But
the
it's actually not.
southwest to the southeast and down to the northeast is Atalanta. Live long and prosper.
Hey there, Ottawa Hinta. How are you doing? Hope everybody's well. Hey there, Tom. Nice to see you too. From the Midwest.
Yes.
Yeah, it's it's but my challenge, right, to myself and to all of you, right, is to come up with an alternative to saying sunrise, right, and sunset, right.
And before you do that, there's also now Carolina Sky Astronomy.
Hey there, Carolina Sky Astronomy. How are you doing? Glad you can join us again. Yeah. So I'm inside for right now, waiting for the sky to clear. It sort of looks like it's going to, but I don't know what the humidity is actually going to do. Let me show you my. I'll show you my weather map here.
And to be honest, I know on TV there might be the Oscars tonight, but you just joined us in the right place, baby.
Oh yeah, are the Oscars going on? Yeah. Well, that's a nice thing, and like I say, as long as people are having fun and having a great time, okay, I don't care what you do, right? So yeah, if you want to be at the Oscars, if you want to watch the Oscars, that is totally cool, right? No problem at all.
I'm not sure if that is actually real or fake, but they said you had built like some type of wall out there to prevent unauthorized people from entering the Oscars.
Well, I guess you don't want any unauthorized personnel, in your little thing. So that's all right, I suppose. Anyway, so here's my latest satellite map, and as you can see, this is from 1:45 UTC, so that was about 25 minutes ago or so, and I'm right about there, right in southeastern Arizona. So here's the state of Arizona, right? Here's New Mexico, here's Utah, here's Colorado, Nevada, California, here's Mexico down here, right? And I'm right about there. And this mass of clouds, you can actually see the Grand Canyon here too. That's what this thing is. But there's this mass of clouds that is sort of rapidly moving eastward, right? It's going off to the left, right? So and behind it, right, looks like some pretty clear skies. It's hard to gauge these kinds of things, but it sort of looks like in the next hour or so it's going to be clearing up, and that's sort of what I'm hoping for. The difficulty is that it's still pretty wet, right? So even though it's going to be clear, right, it might be a little wet. So that's sort of what I'm concerned about. I mean, if you want to call it a concern, is that the humidity is going to knock me out again.
All right, some strongly streams to like keep you up to date. P and K just started out with its infrared observatory session for tonight.
Oh, good. Good. Excellent.
And it's
Excellent.
kind of a bit sucks about what Carolina Sky Astronomy would say if you would check the chat.
Yeah, I'm going to show you my weather here. 85606. Sort of see what I'm up against here. Let's see if it comes back. So yeah, see right now it doesn't look too bad. I don't have any wind though, so I'm not quite sure why it's saying that I might have wind. But it's relatively warm. The humidity is still relatively low, so who knows? Who knows? Hey there, Mike Hunt. Nice to see you in the chat. Wubba lub dub dub. That's an interesting little chant there. Cool. Yeah, well, hey there, Mike. Nice to see you in the chat. Welcome, welcome. So this is a place to talk all things astronomy and space and science and nerdy things like that. So come on in, come on in. Glad you could join us. Hope everything's well in your neck of the woods over there, wherever you're from. This is actually a worldwide gathering, right? So it's great. It's great seeing friends from Australia and England. We even had for a while there was a fellow in Afghanistan,
Brazil.
Yeah. Ingrid down in Brazil, she pops in from time to time. So yeah. And this is just a fun, casual get together of friends. We grab our favorite consumables of choice, sit back on our virtual lounge chairs on the virtual porch, and forget about most things and turn our attention to the universe, which is indeed an incredibly awesome place.
From Canada, Edmonton, Alberta, Canada. And yeah, it's fascinating that, hey, you can smoke weed in Canada.
Oh, yeah. Well, of course.
And
excellent.
Below 30, I think that's usually like Fahrenheit and stuff, because I think in Canada they use Celsius.
Yeah, 30 below is pretty cool. Cool in a temperature way. Why anyone would want to live in that is personally absolutely beyond me. But if you enjoy it, if you like it, stay right there. That is actually very, very awesome. So Uncle Bill says it was actually clear where he was briefly. so yeah, that's a little weird. So
a Sunday weekend at the bar. Interesting.
Cool. Good. Well, enjoy. I mean, this live stream is all about completely enjoying ourselves.
I wish I have a telescope right now as well. I'll be definitely looking at the sky. I got clear conditions, 60 degrees, north at 7 with a 43% humidity.
Wow. Yeah. Pretty nice. So I can do that astronomy with all the smoke. I think it's possible. I think it's possible. So yeah, well, cheers.
Talking about went to the lounge is usually not a great a bar or a lounge is usually not a great place and stuff like that. Ditto when it comes to casino and stuff.
Cool. All right, well, cool. I think what I want to do, I did want to mention really, really quick. because we were having a conversation last night about supernova.
So Cabanza might hunt about channel and stuff.
Oh,
again,
yeah.
Probably again. But probably with more details.
Yeah. Let us know, Mike, what your channel's all about, and definitely check it out.
No, you're not reading the message. So he is saying, so if you don't mind, tell me about the channel we're at. So if you want me to subscribe to your channel.
Oh, I gotcha. Well, I basically just did, right? You know, this is a place where friends get together every single day at 2 hours UTC, and we talk astronomy, space, science, and just a casual, fun, nerdy atmosphere, right? Yeah, that is basically it. If you look down here in the description, you can sort of read a little bit more. I've got some links to my Discord server and links to other things. I forget exactly what they are.
Yeah. And with him watching on the phone, I think what he used to like retract the chat by clicking on that X by the chat, and then like from there, I think he can read the description. If you click on that down triangle and stuff like that, and he'll be able to read the description, and maybe this time he might subscribe for sure.
Yeah, well, very, very cool.
So do that.
Yeah, excellent. Yeah, and that was good for Bobby to remember that you were on a phone. So yeah, that makes it slightly more difficult. But yeah, Mike, just you know, feel free to hang here, listen, and you know, I'm not here, you know, to teach anything or to communicate anything at all. I'm just sharing a passion, right? And this is what I've been doing.
I wonder if Setch Meowit's going to be on tonight. That's what I want to know.
Who?
Setch Meowit on Twitch.
Oh, check me out. Yeah, I don't know. Yeah. I don't know. We're gonna have to.
I know she was on late at night and stuff, and of course I got the Cosmos channel blaring. I just turned it off.
You've been watching Cosmos, huh? Cool.
Yeah, I see Rocket Sage is on.
Excellent. Yeah. Oh, fantastic. I guess. Yeah. Let me mention really quick. We had a brief discussion yesterday about supernova 1987A, and you know, I'm still not exactly sure about that. But every source that I went to find out when it was first seen is saying February 23rd.
And can I make a request, Uncle Bill? If you can post the link of her Discord server, probably on the Discord, because I usually got it like up on the I got the Discord app on my computer. So maybe if you post the link on the Discord on of her Discord server, that would be great.
Yeah. And if he can't, I certainly can. So yeah. But yeah, so everything that I found pointed to the fact that supernova 1987A was actually first seen on February 23rd, 1987. But for some reason in this head, I want to still say that it was January 23rd. But who am I to argue, right? Yeah, not quite sure why I thought it was a month earlier than what it was. I'm going to continue to pursue that a little bit. There was actually a second supernova discovered on that day, 1987b, was actually discovered that same day, February 23rd, 1987.
And we got a troll. We got a troll, so you are
a troll?
Out of here.
Okay, yeah. Sorry about that, Mike. That's how it goes.
No, you do it like a WWE referee. You are out of here. You see, you do it. Yeah.
Very cool. Very cool. All right. The mods are on top of things, just banging stuff down. So I hope at some point that Mike Hunt comes back in and actually wants to do astronomy. So yeah, I think that'd be great. So but until then, peace, cheers, and all of that. So cheers to trolls.
Yeah.
Thank you, Mr. Bobby.
And that troll is once again out of here.
All right. Well, I think you enjoy that a bit too much, Bobby.
Hey, that's what you get when you got like sometimes trolls on Jules' channel as well. I'm usually like this.
Wham, bam, very cool. All right, well, cool. So yeah, I need to investigate Supernova 1987A a little bit more, and you know, in poking around that yesterday, found a pretty cool site, a supernova site that doesn't seem to have all of its information in there yet. Yeah, there's a little bit of confusion about that too. So I think I posted. Yeah, you know, I posted it over on my Discord server. Let me go grab it from there, and I will post it. I will post it here. Let's see, where did I put it now? That is the question. There it is. So I will post this on the chat. Copy, and then I'm going to paste like that. There we go. Yeah, well, Beetlejuice is going to probably do it at some point. You know, when and how is up for question. Who knows? Who knows? Maybe there are things about stars that we don't really understand, and maybe it won't, right? I don't know. Or maybe it already has, and that information right now is traveling to us at the speed of light, right? And tonight, it will finally reach us. So you never know. You never know. So yeah, it's but yeah, you know, if the current all right, we got another one.
Yeah, and he's going to be out of here too.
Very cool. I've, you know, just come on in. That you know, it's sort of an indication that you know, this channel is getting a little bit more popular, and I suppose that's okay. So it definitely keeps Bobby excited over there. So you know, I mean, if nothing else, that's
yeah, Tom is correct too.
Yeah, I think it probably was. So that's cool. That's fine. You know, I mean, that's the environment we're in. Now, I think what I'm going to do really quick.
And Charles best better repent those professional noobs.
Yeah, I can hear that I'm being summoned at the door. So I think what I'm going to do is I'm going to share my screen really quick. I'll show you the my latest satellite view here, and while you're looking at that, so this is as of 25 minutes ago. I'm going to try to update this. Yeah, see, it's starting to clear up, but hold on, I will be right back. I just need to do my duty here. So I'll be right back in like 15 seconds. You coming in? Okay. Are you going to be in here? Do the live stream? Okay. We are back. And in the lap she goes. So let me start doing this. We've got Bobby all excited here, so that's good. Hi. So here she is. She was screaming at the door, so I had to let her in. Agatha. This is Agatha, and she's a sweetie. She usually sticks right next to me most of the time. So hello there. I hope everything's well. Huh? Yeah. Hi. You're gonna knock over this book and everything. Kitties are good at that, knocking over things and standing on wires. Yeah. Yeah. All right. Well, cool. Let's continue going through the constellation of Leo. And I pulled up Burnham's Celestial Handbook, Volume 2, and these three volumes are in alphabetical order by constellation, right? So in volume 2, we have the no, you cannot drink from that. No. You're a pest. She wants to drink from the HOH, and it's just not going to happen, dude. It ain't happening. Not a chance. Why don't you come down here? There we go. So yeah, the constellation of Leo is highlighted in volume 2, and we've been sort of just slowly, gently going through this rather large constellation, so what I noticed was that there's a very nice, well-known, or moderately well-known variable star called R Leonis. It's just the letter R, right? And it has the distinction of being one of the brightest of the long period variable stars. So it's just a single star. At least, this is the story. It's just a single star. Hello. Ow, ow, ow. Nasty. Biting too hard. That's actually, expanding and contracting, right? It's actually physically changing size. And I need to find out if this star actually brightens as it gets smaller, or if it brightens as it gets larger. Boy, we are really going after fingers tonight, aren't we? Hello there. Look at that happy face.
Dude, what in a great tarnation is this professional noob is really doing?
Professional. He's a pro. Cool.
You better.
Okay. Well, that's cool. That's cool. It's I I think, getting that kind of attention is kind of interesting. So, that just means that, the channel is doing better. It's reaching a wider audience. So cool, cool. Um, let's see, but yeah, it's Beetlejuice is on its way. Anyway, so our Leonis. So actually, Burnham's has a couple of pictures showing when it was at its minimum, right here, and when it was at its brightest. So you can see that wow, I mean, it goes from something quite faint, that we can't really see, to something very, very bright. Now, these pictures are sort of deceiving, right? Because it sort of looks like this is small and this is large. No, that's not the case. That's not the case. These are photographs. So when something is brighter, right, that light sort of leaks into it, sort of oozes out the sides, right? So it makes objects look like they're physically larger when they're actually not at all, right? It's just they're brighter, right? So I mean, we can't see, not from here, not with these kinds of photographs. We can't actually see, the actual star itself, right? I mean, you need extremely um, 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 sophisticated pieces of equipment to be able to, discern any actual star shape, right? Um, but those kinds of things are happening now. So what we see is just a single point of light that is getting brighter and fainter and brighter, right? And they actually have a little light curve here for us in Burnham's, showing along the x-axis there the number of days, and then along the y-axis showing the magnitude, the actual visual magnitude. Now, sixth magnitude, this line right here, is sort of the limit as to how faint we can see things with our own eyes, right? So anything lower than that, or in this case, a larger magnitude number, right, which means fainter, we're not going to see unless we use a telescope, right? And as you can see, it varies, and it has a period of what, maybe about 300 days or so from peak to peak here, right? A little bit more than 300 days. It goes, from 200 to 500 or so, something like that. But where this tops off is slightly different in height as here, right? And same here, right? See, this got a little bit fainter than that one. So it changes constantly, right? And that is one of the cool things about the universe, is that not only are things happening, right, all the time, but they're changing all the time too. They're always just slightly different each and every time. Every single time you look, it's slightly different. And I mean, we notice these kinds of things in the world around us, right? We walk by a river, right, and we see the flowing water, right? Well, it's not the same water every single time, right? And if you look at the individual like waves or ripples, they're always changing, right? There's a general, you know continuity to things, right? But you know depending on how you look at it and how long you look at it, things change, right? And things are changing at every single scale. So I got to sneeze. I'm gonna not sneeze. Oh man, it went away. Man, I get a 0. Bummer.
Dang it.
Dang it. Dang it. All right. Anyway, so our Leo, let's see what else Burnham's has to say about this. It's pretty close to the star Regulus, right? Relatively close. Here's a little, they actually even provide a little finder chart, right? So if you want to go out with your telescope and just visually try to estimate how bright the star is, they tell you what the magnitudes of some of the stars around it are, right? So you could go out with a telescope and actually look at this guy and compare it to these other guys and probably make a pretty good, accurate guess as to what its magnitude is at that time, right? And there's a lot of visual observers who do that, and they can usually get about 1/10 of a magnitude accuracy, which is really, really good, right? Really, really nice. So, all right, well, cool. I think probably what we should do is check this guy out over on Simbad. Maybe, maybe before we do that, let's go over to the AAVSO, the American Association of Variable Star Observers, and see what they have to say about our Leonis. So I'm gonna get myself over there. I'm gonna check my satellite image one more time. Okay, cool. I'm going to go over here to aavso.org. And now I'm going to share my screen. Got to do the share the screen music.
Trolls ain't worth it. Trolls ain't worth it. Boom, boom, boom. Trolls ain't worth it.
All right, so here's my latest satellite loop as of 2:15. So this is as of about 25 minutes ago or so. And it's sort of looking like it's starting to clear up. I can actually, I don't know if I dare run this satellite loop, but I'm going to anyway, because that tends to sort of hang my machine, but I'm going to do it anyway. You can sort of see what I'm up against here, and it looks like it's maybe I'm just right on the edge there of it starting to clear up out there. So, and again, this is as of 25 minutes ago, so you never know. Anyway, this is the AAVSO main site, and this is a great site. So yeah, let's go over to the Variable Star Index, and probably what we should do first is just look and see. Now, I think I showed this to you before when we first dove into the constellation of Leo, but I'm gonna show you again because I just want to give you a contrast. Right, show you a little bit of a contrast here. Now, Burnham's Celestial Handbook, I think came out, I think the version that I have is probably the early 80s, right? So quite a while ago now. And they have an entire page just listing all the known variable stars, right? And actually R is the first one at the top here, but these are all the known ones as of the printing of this book, or at least the ones that have some kind of interest, right? So now I'm going to share my screen again, and we will go over to AVSO, and we will look and see how many variable stars are now known inside of the constellation of Leo. So I'm going to go back over here, right? And I'll zoom in a little bit so you all can see what I'm up to. So I'm just going to go to the constellation of Leo here. This is in alphabetical order. There's Leo. And we're just going to look at the variable stars, right? Just look at the variable stars. And I'm going to order them by variable type. Not for any particular reason except just to be able, to put all the different types in a nice order, right? So here we go. We're going to look at all the variable stars in the constellation of Leo. So here we go. So here they are. It says 3,235 records. Maybe I'm thinking that maybe we looked at this before when we first started looking at the constellation of Leo. I'm not exactly sure. Anyway, so there they all are. There are thousands of them, right? Thousands, different types, right? There are dozens of different types of variable stars now. From the type that is Leo, or I'm sorry, our Leo, which is I think they characterize that as like a Myra variable. So it's just a long period variable single star. Anyway, but yeah, just totally amazing. I'm always amazed by these lists. And as you can see, the names over here, these usually they correspond, to different survey names, right? So some survey has gone through and found all these things, right? So just on and on and on, thousands and thousands of them. Pretty amazing. I'm going to quickly scroll through them all. You can see that it just goes on and on. So, I mean, right here, you have multiple lifetimes of work, right? So, and this is just, the constellation of Leo is pretty large, but it's just absolutely amazing. And I mean, a lot of these objects are really faint too. 20th magnitude, right? That's really faint. You need some serious aperture, to see that, right? So you're not going to see that in a small scope, right? You need 1 or 2 meter class telescopes to really see that. So all right, I think I'm being summoned again really quickly here. Let me I'm going to pause just for a second. I will be right back. Let's actually get to our Leo here. How am I going to do this? Oh, I'm not. I'm going to search for it this way. Oh, come on. Our Leo. Whoop, our Leo. There it is. Okay. Let me do my additional duty. I'll be right back.
Phenomenon. Phenomenon. Phenomenon.
All right. So our Leonis. Lots of observations. Wow, almost 100,000 observations of this thing. Holy moly. So yeah, it's very, very well known. Lots of other names, right? Same kind of thing. And at least according to this, it can get as bright as magnitude 4.4. Wow. Wow, that's really, really bright. And really, really faint, down to 11.3. So that's the whole range, right? That's, you know, looking at it, you know, sort of one cycle through, you're not going to see it get that bright and that faint, but it's going to be somewhere in that range, right? This is just, you know, the brightest that's ever gotten and the faintest it's ever gotten. And let's see, it's got a period of 309.95 days. Let's look at the ephemeris, which is it's just a listing of the actual midpoints. I guess that's when it's probably when it's at its faintest. I think that's how I would sort of read that. And yeah, well, its next faintest point in 2019 is going to be on the 5th of September. So at the moment, it is dimming, right? Dimming at this point, and yeah, slowly getting dimmer and dimmer and dimmer. Let's see if we've got any AAVSO light curves from this guy. Hopefully we do. I'd be surprised if we don't, but you never know. Oh, there we go. Wow. Okay. So along the bottom here is what's called the Julian day, and that is just another way of measuring time, right? And I'm going to X that. I'm going to try to X that out. Cancel that. I try to do that. There we go. So you can see that this is spanning quite a long time. I'm sort of thinking, what, 245, about 4,500 over here to 8,500 over here. So that's about 4,000 days, right? So that's quite a few days. Interestingly enough, you know, for reasons unknown, look at the magnitudes up here. They seem to be so much brighter. And I'm thinking the reason why is because that's probably looked at different wavelengths, right? So this is showing everything, all the visible. I'm not quite sure what faint means. BVRIJH. How do I scroll over? I don't know. Let's turn some of these off. Let's see what happens. Ooh, okay. So there's those gone. That gone. There's the B. The V is the green. R is the red. Okay, so I are the pink hexagons. I got you now. Okay. J is the pink diamonds. H, so yeah, this guy is actually very, very bright in the infrared, right? That's what J and H are, and I, for the most part, is towards the infrared. So yeah, I mean, I'm pretty sure that this is a red star, so it is probably going to be brighter in the red than it is anywhere else. But it's pretty sparse in terms of the data in the infrared, right? V magnitudes, that's pretty well covered. Let's turn all these off. Can I turn them all off? I don't know how to scroll over.
Well, I think like maybe if you uncheck the all mark, go back on the top.
Yeah, but
Maybe that would.
then okay, so I just
Yeah.
whoop,
Yeah, and maybe check it back again.
it came
And then
back.
like I think there's like a little scroll box like at the bottom of where the check marks are at, and then you go from there.
Ah, there you go. Thank you, Mr. Bobby. Yeah. Wow. Okay, so I'm some of these I'm not quite sure. I think this might be Sloan green and Sloan red and Sloan I. Sloan is just a different survey. Anyway, here are the visual observations, right? So these are just magnitude estimates done by eye over the years, and that definitely has what looks like the most amount of data, 11,765 data points. Not quite sure what faint means. That's yeah, not quite sure what that means. Here's through the B filter, Johnson B, Johnson V, Johnson R, Cousins I, Cousins J, which we were looking at before, Cousins H. Cool. Or maybe this is Cousins V. Yeah, I don't know. It's just kind of neat to see all these anyway. So pretty cool. Definitely, you know, if someone wanted, to set their system up to look at this object, in the infrared, you definitely have an opportunity here to contribute, right? Because there ain't much there, right? It looks like here, they sort of went through a minimum, maybe that's a minimum, maybe not. Maybe it's a local minimum, and the minimum is actually way down here. Who knows, right? We don't know. Not from this data, at least. But cool. Okay, so that's all of it again. Yeah, there we go. So pretty nifty. And as you can see, even the visual observations, sometimes it peaked really bright, and the next time it peaked much fainter, at least a magnitude less, right? So kind of interesting, right? Kind of interesting. And then the intervals between these change as well. And so people are always interested in trying to understand why, right? Why would that change? Is there a companion that is influencing it in some way, or is it something internal? Yeah, always lots of questions. And this is just data that the AAVSO has. There's probably lots of other data out there too, but you'd have to go and dig for it for sure. All right, well, cool. That's kind of nice. There's there's all kinds of other information here. I think there's another light curve thing. I'm not quite sure what ASAS stands for. Oh, it actually said there. From the All Sky Automated Survey. Cool. Okay. So I know that's a little bit hard to see, but sort of looking like, yeah, same kind of thing. Pretty cool. Pretty cool. Pretty nice. Pretty nice. Let's see. What else do we have here? Doesn't look like much else. So let's dive over to Simbad and take a look and see. Kind of curious to see like what kind of recent research has been going on this star, and let's look at a picture of it too. Hey, it's a bright red star. How about that? Surprise, surprise. You can zoom out a little bit here. So yeah, pretty bright red star. You can see all the other, because it's so bright, we're seeing all kinds of internal um, 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 weird things with the optics, right? So we're seeing diffraction spikes, which is pretty normal, and then all these rings, and that's this stuff is actually in all of these stars. It's just that it's so faint you can't really see it with the other stars, but you can see it in some of the brighter ones. But yeah, let's sort of zoom out here. Boy, that's a nice red star, and there's a beautiful blue star right next to it. That's pretty cool. That's pretty nice. So that would be a nice thing to actually see in a telescope, right? Nice bright red star right next to a bright blue star. That's always nice. Reminds me of Albireo. So let's zoom out here and see. I was mentioning to Bobby in the pre-show that Leo is pretty rich in galaxies, so we should be able to pick out some galaxies here too. Let's see. This is the Digital Sky Survey 2. Let's go to the Sloan Digital Sky Survey Release 9 and see if there's anything else there. So this star is just way too bright for that kind of a survey, so it's just being blasted, right? They're doing as good as they can, to deal with it, but that's just way too much for the system to actually deal with. But yeah, wow, I'm really not seeing a lot of galaxies. There are some here, right? There's a couple of really faint ones, but wow, I'm just seeing lots of stars. Here's some galaxies here, it looks like. Oh yeah, they're starting to pop out now. Yeah, here's some galaxies here. That looks like a star. Yeah, this is definitely a galaxy. Look, you can even see this one's a little bit of a spiral here. Cool. That one might be too. These galaxies are very far away, right? They are tiny, and they probably aren't intrinsically small, right? I mean, these galaxies are probably on the order of the size of ours, right? So the fact that they're so small means that they are really far away, seriously far away. But yeah, all the stars here that we're seeing are in our galaxy. They're foreground stars. So here's a nice barred spiral galaxy. Wow, look at that one. Isn't that great? Now look at this. I'm not quite sure. If that's a star or a very blue galaxy. I'm not quite sure. This looks like an elliptical galaxy. It's almost round. There's an edge-on galaxy. So, wow, yeah, lots. Well, as you probably know, there are lots of galaxies out there. Lots and lots of galaxies. There's another big bright star of some sort being just blasting out. Often it's kind of fun, to see what kind of weird things you can see, with these bright stars. So cool. Very cool. Nice. Let's go down here really quick and see if there's anything else particularly interesting. I'm not seeing any big galaxies, right? Nothing really incredibly nearby, but they're all pretty amazing, right? I mean, I can imagine, right, that there is somebody sitting here in this galaxy going around one of their stars, looking at ours and doing the same thing, going, wow, there's lots of galaxies out there. There's another nice one. Nice spiral armed one. Pretty cool. Right by an elliptical, it looks like. This looks like maybe a star and a star and a star. One of the things that we're trying to do now is teach computers to be able to recognize, the differences between a galaxy and a star, and actually be able to classify these things, right? So we don't have to necessarily have people doing it. And the computers are getting pretty good at it. So pretty nice, pretty nice. This is just in the vicinity of our variable star R Leo. Now, where did R Leo go? There it is. Big bright red one over here. So pretty nice. Some nice stars in the vicinity as well. Lots of galaxies in the background. But as I said, I'm not really seeing any big ones in the area, right? There's some pretty nice small ones, lots of small ones, but don't really see anything big. Oh, did I zoom out too far? What did I do here? Yeah, I just zoomed out a little bit too far. All right, well, cool. All right, let's take a quick look at the references here. Let's see. So relative to us, not really moving very fast, just sort of the normal numbers here. Spectral type M7, so it is definitely a very evolved red star. And yeah, wow, look at the magnitudes. It actually goes negative here when you move to the infrared. So yeah, that's pretty seriously bright in the infrared. But of course, we can't see in the infrared, so it's not going to appear that bright to us. Lots of different names, of course. Lots of references. Let's see how far away this thing is. So actually pretty far away, right? 71 parsecs away. Let's see, 71 times 3.26. So something like 230 light years away. So pretty far away. Pretty far. See anything else here? Pretty consistent with the spectral type. Sweet. Let's look at some references here. Let's sort of look at the latest and maybe the earliest And we're going to actually search for our Leo. Silicon oxide masers in asymmetric miras. Silicon oxide, cool. Processing planetary magnetospheres in silicon oxide stars. First detection of quasi-periodic polarization fluctuations. So, wow. So that was from 2009. Is your doggy okay?
Yeah, I think I might have overpooed it.
Yeah.
I'm sorry, Blackie.
Yeah, that happens. You know, we humans always mess things up. So, yeah, I guess they're seeing a silicon oxide maser, which is kind of cool. I think a maser is a laser, except it's in the millimeter range, right? So as opposed to being, you know, in the visible part of the spectrum, I think the M in maser has to do with millimeter wavelength. Let's just confirm that. MASER. Micro
definition directly from the Google page.
Yeah. So microwave. Yeah. Yeah. So yeah, they're seeing microwaves from these molecules, you know, silicon oxide, coming from the star R Leonis. Kind of interesting. Let's, since this one's specifically talking about R Leonis, let's take a look. So they're looking at the 7 millimeter wavelength band. Let's see what ADS has for us here. Sweet. Dun, 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 dun. The paper loading music is now playing. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Boy, it's taking its time. Look at that.
Yeah, baby, what the deuce?
It's just creeping along here. I'm going to get rid of that. Okay, so silicon oxide masers and asymmetric miras, R Leonis. Asymmetric structure. Cool. Silicon oxide masers. So towards the end of their lives, stars of a few solar masses go through the asymptotic giant branch phase, during which the core has exhausted its fuel and collapses, while the outer envelope becomes very extended and is eventually lost, which may lead to the formation of a planetary nebula. Dramatic periodic oscillations driven by, or actually driving the mass loss, right? So every single time it pulsates, it's sort of shooting out stuff, right? So you definitely don't want to be around this star when it's doing that. That would be a little harsh. Look at that. They are seeing dihydrogen monoxide. I always like to see that. Cheers. Cheers, cheers. Okay, cool. So let's see. The masers appeared within a few stellar radii of the surface, where the silicate dust forms. Partial rings, wow. Okay, so yeah, this is sort of a typical paper where they give an introduction, right, and they just sort of lay out what's going on, what the current understanding of things are, and then the next section, they talk about their specific observations. Now, where are these folks from here? Let's see. NRAO. Looks like, yeah, looks like they're all from the United States, right? NRAO, Goddard, JPL, Iowa State, Harvard. Cool. Sweet. So all from the United States. Let's see, this was published in the Astrophysical Journal back in 2009. Shows evident ejecting a substantial amount of material, largely to the west. This is interpreted as an event in which material is expelled in a collimated flow, possibly following an energetic event. Cool. All right, so these are the observations they made. They used the VLBA, the Very Long Baseline Array, which is a I don't know if I don't know if VLBA is still running, but it's this setup where they have a bunch of telescopes, of radio telescopes around the world, right? And they make their observations, and then after the fact, they can combine their observations and actually get some pretty high resolution stuff. And so yeah, they are looking at specifically silicon monoxide, I guess you'd call it, at these two frequencies, right? Let's see. Yeah, they use so stellar pulsation phases of the observed stars. So here's our Leonis right there. Not quite sure. Okay, so these are just not quite sure what these dates are here. Pulsation phases. Maybe this is the actual phase. Well, I'm not quite sure what these numbers mean here. Anyway, yeah, just describing how they got their data, how they calibrated their data. Of course, that's extremely important. And I guess what we're seeing here are Leonis at several epochs. So the total intensity as a grayscale, circles have a diameter of 50 milliarc seconds. So yeah, I'm not quite sure the angular size of this star, but of course 50 milliarc seconds is pretty small. My guess is that the star is probably actually much smaller. But what they're showing here, right, is that they're seeing emission at these frequencies at these various places, and yeah, it seems to change. Now, why? I'm not quite sure. Let's see, the circle. Okay, so these are at two different frequencies, right? So, I'm trying to go up here. Let's see. The left column is at 42.8 gigahertz, and the right column is at 43.1. So you can see for the same days, right? October 23rd, here, I'll zoom in a little bit more. So for October 23rd, at one wavelength, we're seeing this kind of a structure, and at a different wavelength, same day, same epoch of observation, we're seeing slightly different, right? I mean, there's a little bit of a correlation maybe here, but yeah, there's emission here where there isn't here. There's a little bit off the bottom here, a little bit off the bottom. Pretty cool. So here's on a different date. What this was October 23rd of 05. Here's February 3rd of 06. So several months later. See, that's one of the problems of of being a professional astronomer, right? Is that you don't get a chance to observe these things very much, right? You get a little bit of telescope time, and that's it. So I mean, this is several months have gone by between these two observations. There are substantial changes, and it'd be nice to be able to see what happened in between, right? What a pain. Because
Thank you, Uncle Bill. Let's be out. It's about to start.
I didn't catch all of that. Oh, check me out. Cool. Yeah. Very, very cool. Good. I'll have to, if I'm outside, I'll have to listen to her on my smartphone out there. And then again, they observed it on April 9th, right? And again, it's like completely different, right? So, we have to remember, right, that the variability period here is about 309 days. So that's about 10 months. So over the course of, between October 23rd of 2005 and April 9th of 2006, that's only what, 4, 5, maybe about 7 months or so. So, not even one variability period. They're seeing some huge changes, right, in where this stuff is, right? I mean, basically what you're doing. See you later, Atta. Basically, what you're doing is looking at this material, supposedly sort of flying off of this star. Can't really tell, but maybe that's what's going on. Cool. Okay, so here's some more. Okay, so yeah, these are later days, right? So yeah, lots of activity here, right? And then it sort of dies down. So yeah, hard to know what's going on there. Pretty cool though. Pretty cool. A very, very, very active and constantly changing star, right? Ejecting material. What a busy place, right? I mean, but just like anywhere, right? Kind of cool. Kind of cool. Yeah, these are sort of forming these arcs or these rings. It's kind of interesting. Wow. definitely probably a paper to look at a little in a little bit more detail. Because yeah, they're doing all kinds of interesting things here. Figure 6. Let's go back to figure 6. I want to see what these maps are that they're making here. Because these are so close up from 2004, September 5th. So left and right are the same, different frequencies. Powers of 2 times the RMS. E vector is superimposed. The middle figure is the square root of the total. Intensity is the grayscale. Okay, so I guess these are just more detailed maps. Cool. Lots of stuff going on for sure. Pretty sweet. These maps, by the way, are pretty difficult to make. Radio telescopes are basically single pixel instruments, right? So, you know, in order to make a spatial map, they actually have to scan, right, in some kind of way, right? So it isn't just a matter of pointing and taking a picture, right? I mean, I've got it easy, you know, with my camera, right? I've got a nice, well, relatively nice wide field of view and all that. No, you know, the radio astronomers, I don't know if you can see this little tiny dot down here. See this black square down here? That is the size of their pixel, right? So they're having to scan this, like, you know, probably, you know, in some kind of back and forth motion, you know, to get this image. So this is an insane amount of work just to collect, you know, the data. So cool, nice. Not a lot of references though. Wow, it's kind of short on references, but that's cool. That's cool. All right, everybody. Well, you know what? I'm noticing what time it is, and I think it's about time for me to get on out of here. I'm going to let me go over to my satellite map one more time, and I'll show you what I'm up against with the clouds. It looks like I've still got clouds in the area, but they're moving away, kind of, sort of. So I think what I'm going to do is I'm going to go out and, you know, there is, you know, these satellite things are great, right? But that was as of 23 minutes ago. So I'm going to go out and actually look.
Yeah.
That
I
is
think,
absolutely.
like, if you see me so many times throughout the feed and stuff, it just tell you that Jesus is watching you, you moron.
Yeah, and I'm going to check the humidity too. I got my little device out there to show me that, and you know, last night I got up to 88%. So we'll see what it is tonight. If it's 80 or more, I'm going to start fogging up. So not going to be any good. All right, everybody. Well, I'm going to get out of here for now. So thanks for coming in again. If you haven't yet, make sure to subscribe. Hit the notification bell on there. A thumbs up if you so desire. Make some comments and spread the word. Spread the word. Tell everybody about this live stream. basically doing this every single day at 2 hours UTC. Sometimes I'm not able to because of whatever, but I definitely try, and yeah, I've been relatively consistent, so not too bad. All right, everybody, I'm going to get out of here for now, so cheers, peace, and all that, and
Live
I will
long and prosper.
live long and prosper. Yes, sir. And I will see you again. I will be here in about 22 and a half hours from now. All right. Take care, everybody. Bye.